Hi, everybody. I'm going to share my screen with you shortly. This presentation is, you see my screen at the moment. Sorry. This presentation is the additional notes on Chapter 5 of the Statistics chapter in your PDE 4 NQF Level 4 exams. Okay. Now I'm going to open. You should see two screens. I've got my notes and on the left-hand side, which I will email to you or provide you with the notes on the WhatsApp group. And then I have Chapter 5 in PDF format. Okay, let's go through this. Section 1, a lot of, starting from page 260, definitions. Okay, so you don't have to know it. Just it's an open book exam. So I made additional notes. I went through that. Okay. So to summarize the whole chapter, I thought it easy to make notes for you. So section 1, we have 5 measurement levels of close-ended questions, and you have the Likert scale. Okay, it shows agreement, disagreement with a statement or a question, where 1 is not very important, 5 is extremely important. You have multiple choice questions. You all know what that is. Then you have ordinal data. Numbers are used to show a ranking, like 1 is extreme likely, 5 is extremely extremely dislike. Okay, or extreme. They will ask you, do you like a bar 1 milkshake? You'll say 1 to 5, you extremely like a bar 1 milkshake, or 5, you extremely dislike a bar 1 milkshake, just for an example. Then you have your categorical answers or categorical data, where you can group. Sorry, I just have to take a sip of water. Where you group the answer in a category. So it can be, what car do you drive? A, BMW, Land Rover, Toyota, Mercedes, or a Ford. Okay. Numerical is real answers, real answers, real numbers. How old are you? Okay. How many children do you have? 1. How many properties have you sold in the past 6 months? 4. So it is a real number, a numerical number. Then we're going to do calculations. This is very important because they do ask you this, okay? Change a percentage into a numerical number. Let's say you have 500 participants in a survey, and only 15% of those 500 participants know of Property 24. Okay, this is how you're going to calculate it. You take 15, because it's 15%, you divide it by 100. That's just a given, okay, because you want to change the percentage into a numerical number. So you have 15, you divide it by 100, and you multiply it with 500 participants. And there you get your 75 people out of 500 knows Property 24 exists. Okay, if you want to change the numerical number into percentages, you have 500 participants in a survey, and only 75 know that Property 24 exists. What is the percentage? Then you're going to take your 75 participants that know Property 24 exists. You're going to divide it by the 500 participants, and you're going to multiply it by 100. And there you have your 15%. Okay, so this is a formula. Mark it as important because you're definitely going to get this one. Okay, now we're going to do, this is also extremely important because they do ask this. Okay, the measures of central tendency. And it is on page 281. Let's go to page 281. In the PDF document, I just want to work the two together, that you are familiar with the content. 281, sorry about this. It takes a bit of a long time. Okay, statistical measurements. There we go. This is so important. Okay, the median is a middle element of a data set, okay, organized from the smallest to the largest. Okay, now they might ask you, okay, they always provide you with a data set. They can tell you there's the numbers 9572. What is the median of 9572? Okay, then you immediately know it's a measurement of central tendency. Okay, you're not going to go to page 28.1. You're going to know you've got it in your notes. Okay, so first of all, you have your data set 9572. You're going to arrange your data set, okay, to smallest to the largest. So it's 2579. Okay, so you're going to, the median is the middle element. So you're going to take the middle element, because 5 on its own is not a middle element, a middle value, and 7 on its own is not. But the two combined is the two middle values, okay, of the four numbers. And then you're going to calculate the median, you're going to 5 plus 7 divided by 2. So the median, your answer will be 6. The median is 6. So in the exam, they will provide you with the data set, and you will provide the answer. The more you explain how you got to your answer, the more marks you can get, because they give half marks. So if you say you've got your data set, organize your data set, okay, mark it 5 and 7, and show how you got to your answer of 6. Show the calculation. You say 5 plus 7 in brackets divided by 2 equals 6. So you will get more marks if you explain how you got to your answer. Don't just say 6, because you're losing marks. Okay, the mean average is the mean. Basically, the mean means average. Okay, it's the sum of all the values that is calculated and divided by the number of values. Now, let me show you. They can say, what is the mean of the data set 9572? Okay, now, first of all, you're going to calculate the mean. You're going to add all these up. 9 plus 5 plus 7 plus 2 gives you 23, okay? But then there's 4 numerical numbers, 1, 2, 3, 4. So you're going to take 23 and divide it by 4, okay? It's quite straightforward. That equals 5.75. So the mean, the answer is, of the data set, the mean is 5.75. And again, don't just answer 5.75. Show the steps, okay? If you want to do the mean, you don't have to calculate or organize the data from small to large, okay? But just show how you got to the answer. You show them the calculations. Now the mode. The mode is not really a calculation, but the mode is the value which occur more frequently in a data set, okay? So this is your data set, okay? They give you the data set here, 2425741. Now you're going to have to arrange the data set to make sense of it. So you're going to arrange it, and then you see, aha, the number 2 is twice, and number 4 occurred twice. So that's frequently, okay? So the modes, your answer will be the modes equals 2 and 4. That's your mode, okay? Now you have your arithmetic mean. Now, your arithmetic mean is basically exactly the same as mean over here, okay, the average. It's the sum of all the values that is calculated and divided by the number of values. Okay, now I just want to go to there. There's the arithmetic mean. They're not going to ask you to do the sum with the symbols, okay? But you will have to maybe show the calculation that you can understand. You will see we're on page 283. Okay, there we go. Okay. Now you have your data set. They can ask you if x, okay, equals 35845. Okay, so if X is 35845, okay, and I did mark it on page 283, which is this page, and I also made a note there for you to understand it better. So then 35845 is the value. If you add it all up, it's 25. Okay, so you calculate it as 1 times 25. Okay, and it's 5 numbers. 1, 2, 3, 4, 5 numerical numbers. 1, 2, 3, 4, 5 numerical numbers. So it's 1 by 25 divided by 5, okay? And your answer will be 5, okay? So there I explained it very clearly here also. So if they ask you, what is the arithmetic mean of X, okay? And the data set they can say is X, and then they provide you with the data over there. And then your answer will be the arithmetic mean of X equals 5. Show them how you calculate it. You can use that calculation. You will see on page 283, using a calculator, one of your statistical calculators, to calculate the arithmetic mean. I don't think they're going to ask you that, but know where it is. You never know, but they're not asking questions. You are allowed to take a calculator, but just, I just took my normal calculator. I didn't take a statistical calculator. It's not necessary for NQF level 4. So, but just know where it is if you need it. But this calculation is more than enough. You can do this sum over here, the calculation, or here. Okay, but just show them how you got to 25. Can you see? Because 1 is there, it's actually 1 to 25, and then the answer is 5. I hope it makes sense. Okay, now we're going to move on to class midpoint. Okay, it's adding the upper and the lower class limits and then divide it by 2. Then you will get your class midpoint. Okay, now let's say the class limits is 1.5 and 2.4. I just want to see. Okay. We're going to calculate. Now, this is the data set. They say, what is the class midpoint for the class limits 1.5 and 2.4? Now, you're going to calculate the midpoint. You're going to take 2.4, okay, plus 1.5 equals, okay, 3.9. So you're going to add it up, okay. Then you're going to take 3.9 and you're going to divide it by 2, which is also quite logical. And then it's 1.95, okay. So the class midpoint is 1.95, okay. So you're adding the upper. This is important, okay. Can you see I added the upper and the lower class limits and then divided by 2. Okay, so there we go. There's your calculation. Your arithmetic mean when using grouped frequency data. Okay, and I want to show you over here. I used the values in there. So this is if you multiply the midpoint by the frequency for all data, okay? You find the sum and divide the answer by the sum of all the frequencies, okay? So over here, they can provide you with a column and say, this is your class in centimeters, this is your class midpoints, this data they will provide. And then they can provide you with a frequency, okay? So to do the calculation, I took the class midpoint, 153, and you multiply it with the frequency, which is 5. There's the calculation. There's the calculation, okay? So your total frequencies is 100. And if you add it all up, okay, so it will be 16,375, okay? So you have this is now the sum, how they did it. Okay, so it's good if you can indicate it like this. And okay, so 153 times 5. So you added there 153 times 5, 158 times 18. You add it all up, okay? That equals 16,375. And then you add your frequencies, and that is 100. So you have 16,375 divided by 100, which gives you 163.75. So that will be the arithmetic mean of the group frequency data. Okay, so the best is for you, I showed you how to do it in the table, but your sum, your calculation, you will show it like this. You will add it, okay, and maybe just put page 284 in the notes, okay, if you review it, okay. So this is very important because you might get this, okay? So you're not just going to answer it and say the arithmetic mean of the group frequency data is 163.75. You're going to show how you calculated it. This is how you calculate it. That's your total. Your total of your frequencies is 100. You're going to take your midpoints, divide it by 100, and it gives you your arithmetic mean of 16375. Okay. Maybe I just want to make a note here and say PP 284 for calculation. Let me just do this bold for calculation. Then you know it's over here. Okay. So I hope this makes sense. Let me just mark this for you, page 284. And then over here, I just want to mark the calculation for you. This is the calculation. So very important, okay. And again, oh no, okay, sorry. Not do this, delete that. And we're going to do that again, sorry. It doesn't want to highlight it now. Let me just move it a bit up and then over. No. Oh, okay. I will fix this anyway for you. Okay. When I send it to you in the WhatsApp group. Okay. So this is very important. Okay. Maybe I can mark it for you with a highlighter. Just like an explanation mark. This is how I do. Oh, lovely, Annelie. Just hang in there for me. Okay. Okay, over here, I just mark the properties. Then you know when you see the red exclamation mark that this is super important, okay? Because you have to show how you calculated it. There's your calculation. I marked it for you. Now we're going to look at the measures, how the data is spread, okay? You get 3. You get the range, okay? I just want to save this file, save it quickly, save, sorry. Okay, the data spread, the measures of spread, we are here. Now, the range. The range is subtracting the smallest element of the data from the greatest. Okay, so now you have your data set. Now you subtract the smallest element from the greatest. So you have the smallest element is 2. You're going to subtract 2 from the greatest element, which is 10, and it equals 8. So the range is 8. The higher the answer, the more the data is spread. Okay, the less numerical value the answer is, then the data is not spread. Then we're going to move, this is straightforward. Your deviation, it's the difference in the value of the data and the mean, the average, okay? The there's your deviation. Okay. Then you have they will give you your data set 100, 101, 98, 95, 17, and 46. Before you can calculate, okay, the deviation, this is quite important, you will have to get to work out the arithmetic mean. So you will get your value, okay, of the data set is 457, and you will divide it by the number of values, which is 6. So because there's 6 numbers, 1, 2, 3, 4, 5, 6, 6 numbers, okay? This gives you the arithmetic mean of 76.17. Okay, now you will need that 76.70, your mean, you will need to calculate your deviation. Okay, let's say they can tell you what is the deviation of x1, or what is the deviation of x2 or x3, x4, x5. So x1, look at page 286, is the first value in your data set. X2 is the second value in your data set. X3, third value, and so forth. There you can see, for an example. Okay, X1, X2, so it's quite straightforward, okay? This is your data set. X1 just indicates the position of the data you must use, okay? So this is now X1, okay? Calculate the deviation of X1, and they're going to give you the data set. Don't think, oh my word, what is this? Remember now in your notes, okay, you know what X1 is. So deviation, you have your data set. You know immediately X1 is the first, but first calculate your arithmetic mean to get to 76.17. We've done this, okay? Then calculate your deviation of X1. You say it's 100, okay? That's X1 minus 76.17. That's standard. That is your sum, your calculation. And your answer is the deviation of X1 is 23.83. Okay, and make a note, deviations can be negative. Okay, so this is how you calculate your deviation. And again, show them how you got to the calculation. So you don't have to know it out of your head. If someone asks you, calculate the deviation of X2, okay, then you're going to get the data set over there, which they will provide you. You're going to find the arithmetic mean, okay, of the value. You add it all up, and you divide it by the number of values. There's 6 numbers, okay? You get your mean of 76.17. Now you will work out your deviation. You're going to calculate the deviation of, let's say, X2. Then it would be 101, okay? So 101 minus your mean, okay? Then your deviation of, if it's X2, will be let me see quickly, 76.17. Then it will be 24.83, okay, if it's X2. So this is what it means, okay? I hope it makes sense. Maybe if you watch the video more than once or make notes as we go along, it will be clearer. Now we're going to look at the mean deviation, the average. This is very important that you're definitely going to get a question, and also deviation and the mean. A mean deviation is the sum of all the deviations, x1, x2, x3, x6. So that's all your data divided by the number of values in the set. Okay, so this is quite important. Also, you're going to get a question like that. Let's say they give you the data set 23.83, 24.83, 21.83. This is your data set, and I marked it for you on page 286 from X1 to X6. That is your data set. Now they're going to ask you, calculate the mean deviation. To calculate the mean deviation, okay, you're going to add all those numbers up. It's going to give you 178.66, okay? if you add everything up, then you're going to divide it by 6, because there's 6 numbers in total. 1, 2, 3, 4, 5, 6 numbers, which will give you 13.11. So your mean deviation of x1 to x6 is 13.11. And again, don't just give the answer, show how you calculated it. And I can tell you now, the measures of spread, the range, deviation, and mean, you're definitely going to get that as well. It's very important. Okay. We're going to move on to probability. Okay. The probability is the measurement of the likelihood of an event occurring. It's expressed as a number between 0 and 1. 0, it's an impossible event, and 1 represents a certain event. Now, you don't have to know this offhand, but know where your notes is, that you can quickly refer to your notes if you need it. The formula for the probability, this is set in stone. PE is the probability of an event. NE is the number of outcomes in the event. NS is the total number of possible outcomes, your sample space. Okay. How you do the calculation of the formula is your probability of an event equals, okay, the number of the outcomes of the event divided by the total number of possible outcomes. Okay, so example, throwing a dice, okay, on page 295 and 296. 295, let's just move on. Sorry, I got a bit behind here. The 295. Remember to mark all your definitions. I'm not going to go through the definitions, and I didn't put the definitions in the notes. I basically just put your calculations in the note. Okay, so calculation using the formula, probability of throwing a 4, for an example. You have 1 chance of throwing a 4, so it is 1. But there's 6 sides of the dice. So you will say the probability of an event, okay, NE equals NE, which is the number of outcomes of the event, divided by the total number of possible outcomes. So you will write it up, the probability of the event equals NE divided by NS. And this is how you write it up, 1 chance out of 6. Okay. Now we're going to move on to the laws of probability, and we're going to come back to the formula of the probability again. Okay. Law 1, if the probability of an event is PE, the probability of it not occurring is 1 minus PE. So it's 1 minus the event. The probability of not throwing a 6 on the dice, okay, the probability of not throwing a 6 is also the probability of throwing a 6, remember we said it's 1, so it's 1 out of 6. The probability of not throwing a 6 is calculated as follow. So it is 1 minus PE, okay? So your number of outcomes in the event is 1, 2, 3, 4, 5, okay? Because you already have, there must be you're busy throwing the dice. So the number of outcomes in the event will be 5, okay? The number of possible outcomes will be 6. So it's 5 out of 6. So 5 out of 6 times you will not throw a 6, okay? So you have 1 chance. So this is how you do the calculation. I hope it makes sense. So you have the but you first have to see the probability of throwing the 6 is 1 out of 6. So the probability of not throwing, okay, is 5 out of 6, because you have already the probability of throwing the 6. So it will be 1 minus 1 6, okay? So this is how you write it up. The event not occurring is 1 minus, okay? Then you have the probability of throwing it is 1 in 6 chances, and it equals 5 out of 6, because it's the probability of it not happening. So it's 1 minus 1 6 equals 5 6. Okay, so this is in statistics. That's the calculation. It always stays the same. I don't really think you're going to get a question like this, but I made it in the notes that it's important that you just have it if you need it. Okay. Law 2 is mutually exclusive events. I think what they might ask you is what's the laws of probability? And then you have the laws over there. Okay. Mutually exclusive events. Okay. The definition is on page 298. Okay. 298. We're going to move to 298 for you. Two events. I did discuss this in the previous training session. Okay. If event A is throwing an odd number, 135, and event B is throwing an even number, 246, the probability of either occurring is 100% because both can occur. It occurs at the same time, okay? So you're going to do the calculation, okay? The calculation is the probability of A or B, which is an event, equals the probability of A plus B. So the probability is 3 out of 6 and 3 out of 6, okay? Because the probability of either occurring is 100%. So half of you always take the half of 100, so it's 50%. So 3 out of 6, it's 50%, plus 3 out of 6 is 50%. So it is 0.5 plus 0.5 equals you 1. Okay, so if you divide then 3 out of 6, the answer, if you divide 3 divided by 6 is 0.5, plus divide 3 by 6, it's 0.5. Okay, so I added this in because in this explanation, it doesn't show how they, so do the calculation and then just in brackets say 0.5 plus 0.5 equals 1. Okay, independent events. The probability of two independent events, A and B, both occurring. So you have the probability of A and you multiply it by the probability of B. That's law 3, independent events, okay? And it's on page 299 over here. Let's see, here's 299. Okay. A and B have a pack of 52 playing cards. Find the probability that they both draw the ace of clubs. So A, the probability is 1 out of 52 because there's 52 cards. And B, 1 out of 52 because there's 52 cards. Now you're going to do the calculation, probability of A multiply by the probability of B. So you equals, it's 1 divided by 52, multiply by 1 divided by 52. There I did the sum for you. 1 divided by 52 equals 0.019. If you multiply it with each other, you get 0.00037. So the probability of A and B will both draw the ace, that they will both draw the ace of clubs will be 0.0037. Again, don't just write your answer, show the calculation. And I think that summed the statistics up. So it's a 3-pager. The notes of the calculations and the important information is a 3-pager. But you have to know your definitions because they're asking a lot of definitions. What does this mean? If I say two events are independent in statistics or in the laws of probability, what do I mean? Then you know exactly. The occurrence of one event gives us no information about whether or not the event, and you can actually just take the answer and just copy paste it. You're not allowed to take a computer in or a cell phone in the exam room. But I mean, you can write it, send. That's the beauty of an open book exam. Don't think just it's there in your book, just write it. The only place where you have to think a bit is with the calculations to apply it to the data set that they will give you. Okay, so I think that's straightforward and I really hope this helped. If you need any more questions, please WhatsApp me or email me. The next chapter will be a bit easier. Okay, so you must have a lovely day and We'll chat soon. And this is me for now. I just want to stop the recording.